Hello, I'm Mirdad Simkani, your calculus professor, and this lesson about antiderivatives. We know all about derivatives. So antiderivatives is just to work backwards. So here are some examples. Example 1. F prime, the derivative is given, it's x cubed. We want to find f of x. And there is also a question, how many answers are there? So think backwards. What function, if you take its derivative, you would get x cubed? You know this is a power, and power functions are the results of taking derivative of power functions. For example, if you take derivative of x to the fourth, you would get 4x cubed, but this is just 1x cubed. So if you divide that by 4, then it will work. So here's an answer. So if I let f of x equal 1/4 x to the fourth, I can check what is what is f prime of x. That's 1/4 times derivative of x to the fourth, which is 4 times x cubed. And then when you simplify, you just get x cubed. So that worked. So this is an answer. The question is this the only answer? We all know that if you take derivative of a constant, you always get 0. So if I add plus 5, that too would work. Derivative of 5 is 0, so that doesn't add anything to the x cubed, so it still works. If I subtract pi, that too works. Derivative of pi is 0, right? So the most general answer you can give is to say f of x equals 1/4 x to the fourth plus c, where c is any constant, or where c is an arbitrary constant. And we just checked the derivative of this is equal to x cubed, and that checks. So let's try another example. Here we want to find the most general antiderivative of this function. For this I can write f of x as a power. So it's 5 times x to the half. Now so you see something about the notation here. Here this is a derivative of a function, but I'm just calling it a little f of x. Over there it was called f prime. So when you take antiderivative of f prime is f. But here, the notation, when it's not called f prime, the notation is to use capital letters. So the antiderivative in this case is denoted by capital F of x. That's a standard notation. If it was called little f prime of x, then the antiderivative is just little f of x. But because the derivative is called f, little f, lowercase f, the antiderivative should use capital F. And what function, if you take its derivative, will give you 5 times x to the half? You know, by power rule, every time you take derivative of a power, you reduce the exponent by 1. So if you do the opposite, you want to do the antiderivative, you have to increase that power. So x to the half changes to x to the 1 more, 3 halves. Now think about taking derivative of this so we can adjust what coefficient to put in front of it. So after you multiply by 3 halves, you get 5. So the algorithm would be to divide 5 by this new power, new exponent, 3 halves, or multiply by 2/3. So if I do 10 thirds, and I can always check what is 10 thirds times 3 halves. The 3's cancel, 10 divided by 2 is 5. That checks. But the most general antiderivative is to say plus c, where c is any constant or an arbitrary constant. So there are infinitely many answers to the antiderivative questions. To each antiderivative question, there are infinitely many answers. Let's look at another example. Now, these are different ways to asking the same question. Going back to these two problems, it was one way to ask the same question. Here was another way. So I am using these different ways so you become familiar with the notation. Now here we're using this symbol here. Right now it doesn't make any sense to use this symbol because this symbol represents a stretched S. So if you stretch the S from up and down, you make it look like that. And S is the first letter of the word sum. Later when we talk about areas and we talk about definite integral, then that symbol makes sense, which represents a sum. But here, because there is a theorem, the fundamental theorem of calculus, that relates antiderivatives to the area, this symbol is traditionally used also for antiderivative. We call it indefinite integral, but it's the same question as above. You're finding antiderivative. So the answer to this question is the function whose derivative is secant squared x, and that function is tangent x. Now there is also a dx here. That too doesn't make much sense in the context of antiderivative. I can justify it a little bit right now, but later again when we talk about definite integral, this is indefinite integral. When we talked about definite integral, it makes a lot more sense. But right now, think of this as a differential dy. So if dy is secant squared, so call this whole thing dy. We talked about differential notations. If you call that dy, then the function y would be tangent of x. If you take differential of tangent, you get secant squared x times dx. But this is just one antiderivative. Just like above, we should add a plus c to indicate there are infinitely many answers. For each constant c, you get one answer. let's look at another example. Here it says solve the following initial value problem. They give you the derivative. In addition to the derivative, they're giving you the value of the function at certain number. This is called the initial condition. This is what we call initial condition. For example, if this function represents velocity and x is time, then this will tell you the position at the beginning, or at time 0 is at -4 on the number line of some object that moves on the number line. So what does it mean to solve the initial value problem? It means to find f. You have the derivative and you have a condition, you find f. This is also called, when you have a derivative equation, it's also called a differential equation. So that's by itself is a whole different course, but it's all based on calculus. So it's just an extension of the calculus. If you're interested, take differential equations later on. I guess you need Calc 2 at least, and also concurrently you may have to take multivariate calculus. Anyways, so what is f of x here? Again, we're looking for a function whose derivative is 3 times e to the 2x. We know something about e to the x. Derivative of e to the x is e to the x. What is derivative of e to the 2x? Derivative of e to the 2x is not just e to the 2x. Because of the chain rule, you have to multiply it by derivative of the 2x, which is the input inside function. The 2x is the inside function. E to that is the outside function. So you multiply e to the 2x by derivative of 2x, which is 2. So right now what I have, e to the 2x, its derivative would be 2 times e to the 2x, but I don't have 2 times e to the 3x. I have 3 times e to the 2x. I can put a constant here, a coefficient, so that after I multiply the 2 by this fraction, I'll get 3. And that fraction should be 3/2. So that's how I adjust. This is just like the power rule for power function, but this is different. We're not using the power rule here. There is no power rule for exponential function. It's called chain rule. You multiply by derivative of 2x, which is 2. And that 2 times 3/2 is 3. And that gives you the 3 over there. But this is not the only antiderivative. You still need to add a c, that stands for a constant. Now, we use the initial condition to find c. So use the initial condition that to find c. So when you have an initial condition, the answer to this problem is unique. You only get one answer, one particular answer, not just infinitely many based on anything you can plug in for c. So to find c, I need to plug in 0 for x and -4 for f of x. So if I do f of 0 here, I get 3/2 e to the 2 times 0 plus c, but I have to set that equal to -4. So this -4 is what the value of the function is at 0, and that helps me to find C. So let's do that. Now to find, first of all, e to the 2 times 0 is 0, e to the 0 is 1 times 3 halves, so this gives me 3 halves plus C equals -4, so I can solve for C by subtracting 3 halves. So C equals -4 minus 3 halves, which is minus, the common denominator is 2, so you get -8 from here and -3, that would be -11 halves. That's the value of C. So the final answer is f of x equals 3 halves e to the 2x, and now plug in plus C, which is -11 halves. And that is the solution to the above initial value problem. Now here's the last example in this video lesson. Again, we have a differential equation. This is a second order differential equation, second derivatives involved. And because it is second derivative, every time you find antiderivative, you have to do it twice. Every time you find an antiderivative, there is an arbitrary constant, therefore you need two conditions, two initial conditions. So these two are the initial conditions for this problem. And before we find f, to solve a differential equation means to find the function f of x. Before we find f of x, we have to find f prime of x. So f prime of x is antiderivative of 2 times sine 3x. So we know what function, if you take its derivative, it becomes sine, and that's cosine, right? Not exactly sine, it's minus sine, right? Derivative of cosine is minus sine. So derivative of minus cosine would be plus sine. So we know there should be a minus and there should be a cosine, and the arguments should be the same. Don't forget the chain rule. Derivative of cosine 3x is what? Minus sine 3x times 3 by chain rule, right? Derivative of the inside function is 3. And then with the minus I've put there, minuses cancel out. But I'm getting 3 times sine 3x, while I want 2 times sine 3x. So what should I do? I should divide 2 by 3. So you divide by the derivative of the inside. You know, this for x squared, it won't work. You know, only if it's a constant times x here, it would work like the power rule. But if this was, instead of 3x, it was x squared in the original question, then it would not, this would not work. Okay. Later we learn more techniques, especially in Calc 2, techniques of integration. In this course, we only are able to find certain easier types of antiderivatives. You study these types of problems in more depth in Calc 2. So now I have, actually I forgot something here, and that is plus a constant, right? Because there's going to be another constant. Don't call both of them C. I'm going to call this one C1, C sub 1. But I can find C sub 1 here. There is a condition f prime of 0 equals 1 that's given. So I can use that to find C1. So let's do that next. So here f prime of 0 is minus 2/3 cosine of 3 times 0, which is just cosine 0, plus C1, and that must equal a 1. So this comes from here. Okay, so f prime of 0 is 1, so I have to have f prime of 0 equal 1 over here, and that helps me find C1. Cosine 0 is 1. We know that from trigonometry, from the unit circle. So I add 2/3 to both sides, so C1 is equal to 1 plus 2/3, and this gives me C1 equals 5/3. Now I can rewrite f prime. So f prime of x equals minus 2/3. I'm just copying f prime from above. The only thing that's new is to substitute 5/3 for C1. So that's that. And now I have f prime. Now it becomes just like the previous problem. Do it again. Find antiderivative of this function, which is lowercase f of x. Now again, we're dealing with sine and cosine. You know, they go back and forth. So antiderivative of cosine is sine. So if I have sine 3x, its derivative is cosine 3x times 3 by the chain rule times the derivative of the inside function. But instead of cosine 3x times 3, I have negative 2/3 times cosine 3. So I have to adjust the coefficient. The minus stays, and the 2/3 has to be divided by this 3. So that becomes 2/9, because 3 times 2/9 is 2/3. And then plus antiderivative of 5/3. Just like when you take derivatives of a function plus another, it's the sum of their derivatives. Antiderivative is linear in that sense too. So if you take antiderivative of a sum, you get sum of antiderivatives. So now I need antiderivative of 5/3. And this is just a constant, and antiderivative of constants is just a constant times x. Why? Because derivative of 5/3 times x is just 5/3. And then, before we forget, plus another arbitrary constant, C2. Now we find C2 by using this initial condition. So f of 0 is 5. So I'm going to use that to find C2. F of 0 is equal to minus 2/9 sine 0 plus 5/3 times 0 plus C2, and that must equal 5 from here, 5. So that's where this is coming from. This 5 here comes from that initial condition. And now I'm going to solve this for C2. First of all, sine 0 is 0. 5/3 times 0 is 0. So what we get is C2 equals 5. So now we can find or write the final answer. So f of x, the last statement about f of x was this, minus 2/9 sine of 3x plus 5/3 x plus c2, which is 5. And this is the function that if you take its second derivative, you get 2 times sine 3x. Okay. Let me I want to separate the question from that's okay. So the question is let's see. So the so this is the question, and down here is the solution. Okay, so you can always check your answer, take the second derivative, first f prime and then f double prime, and then you get that. Also plug in 0 for x in f, you should get 5, like that. And when you take its first derivative, plug in 0 for x and then check to see if you get 1. So this is the way to check your answers. So this was my last example, and this concludes the video.